Now, this is the really exciting bit. So, Jeremy Brett is one of the consultants that we've used to help augment our geophysics exploration strategy. He's based over in Canada. He's worked in Botswana. He's very experienced in Botswana. He's worked on the Copper Belt. He actually worked historically in the KSZ. So when I made contact with Jeremy through one of my contacts back in February, he was very happy to get our call because he'd been watching Kavango as it happened since Kavango formed. You know, it's a project that interests him anyway. So one of the things I asked Jeremy to do for us recently, because we've got a number of questions from shareholders, was to provide a table for us giving sort of a range of estimates of subsurface bodies and the type of conductance that they give off. Now, what you can see here very, very clearly is that a Siemens reading, so Siemens, as you can see on the left-hand side, and this is the conductivity, a Siemens reading of 2,500 to 3,000, which our two targets both have, that puts us up, you know, in terms of expectation, the lower end of massive sulfides. So whether we find sort of economic discoveries at this point doesn't matter so much, because obviously what we're doing this year is proving up the concept. If we can find massive sulfides at the bottom of these keels, then it's game on for the whole of the KSZ, because we've then at that point proven the theory. And the fact that both of our targets are giving off, you know, they're strong conductors. They're giving off a very clear indication that these are massive sulfides that we're looking at. This is why we're so excited. So of course there are no guarantees. We've done everything we can to rule out other subsurface bodies. So burnt coal, for example, is one of the possible concerns, because obviously as the magma passed up through these conduits and interacted with the local magma, it actually burned the coal to melt it into the magmatic mix. So what we think we found so far, you know, it does all look very encouraging, and based on, this is sort of widely known information about sort of the kind of readings that other subsurface bodies give. You know, we look like we're at the lower end of massive sulfide. So this is very encouraging. I mean, obviously it'd be great if we were higher up the scale, and we're looking at, as Jeremy calls it, you know, real barn burners of targets. So we haven't quite got those yet, but you know, if we can prove the concept, then you know it be up to us to go out there and deploy more of these TDEM surveys to identify more targets. So for example, in these other keels that we're looking at in target area C, we have other keels in A and B that we're also looking at. And those are just like the three areas that we've really focused our energies on over recent years. We've still got the whole of the rest of the KSZ to go for. So the potential here really is enormous.
Okay, good. Thank you very much for explaining that, because I did see you put that out on Twitter, and initial glance at it looks very complicated, but as you've explained it there, that's very straightforward and also very promising. So yeah, thank you for explaining that. So yeah, go on, Ben.
Just before we move on, yeah, I mean, look, it does look pretty complicated because it's a pretty thorough piece of work. I mean, he's obviously put up all the different types of bodies that, you know, that we could think of, and with an idea of the range of their conductance. And you know, it's I mean, the key thing to look at here is, I mean, maybe we should have highlighted it, but I think it is fairly self-explanatory sort of now that I've explained it. The fact we're in this area and we think we've ruled out all of these, not proven yet, but you know, it does look very encouraging at this stage.
Good to hear.